Hello there, welcome to the show tagged The African Data Scientist, a podcast where we get to tell the story of the African AI and data science potential. I'm your host for this episode, Stephen Oladele, and in this episode we had an insightful conversation with Dr. Sebastian Raschka, who is one of the most prominent persons in the AI and machine learning community. He gives a lot of valuable insights on what to focus on as a researcher, how African countries can go about adopting an AI curriculum to their educational system, as well as the challenges he faced while starting out and what it takes to write a good book. Major links mentioned in the show will be in the show notes, so you can check them right after listening. And if you enjoy the show, please rate 5-star wherever you're listening to the podcast, share with your colleagues, and enjoy the show. Hello, Dr. Sebastian Raschka. How are you doing today?
I'm doing fine, and it's a pleasure talking to you today again. So I remember we had a brief conversation at the Port Harcourt School of AI, the conference a few weeks ago. And it's my pleasure to be here again and talking to you.
We're absolutely delighted as a community. We're very excited you took out your time to join us today. Thank you so much. So Dr. Sebastian, of course, it's no denying that you are one of the most prominent figures in, the machine learning community today. And therefore our listeners may already know a lot about you. Well, can you tell us what they don't already know about you as you try to introduce yourself?
Thank you for the kind mentioning of me being one of the prominent figures in machine learning.
Sure.
I'm not so sure about that. For people who maybe don't know about me, I'm currently a machine learning or assistant professor of statistics teaching machine learning at the University of Wisconsin-Madison. Maybe people also know me from my blog. I was blogging quite a lot when I was in grad school. And then at some point in 2015, I started writing a book called Python Machine Learning. And that is a book that was updated now 2 times. So there's a second and a third edition. So chances are that you heard maybe about one of the 3 editions. And besides machine learning and deep learning research, I also often collaborate with people in the field of computational biology, where we mostly care about drug discovery, ligand discovery problems, where we use mostly machine learning and deep learning to discover small molecules that can be targeting certain proteins, maybe involved in diseases, but not always. But the goal is also to use machine learning and deep learning for something productive or useful.
All right. Thank you so much. I mean, if you've not heard about Python machine learning, listeners, then I don't know where you've been in the ML industry, because that's a really, really amazing book. Thank you once again for writing such an amazing book.
Thank you. I really appreciate that.
All right. So, Dr. Sebastian, when did you decide during your career that you were going to spend more time in the academia? Because you mentioned, of course, you're a professor of statistics, associate professor of statistics at the University of Wisconsin. When did you decide during your career you were going to spend more time in the academia as opposed to the industry?
That is a very interesting question. And it's a very tough question, actually, because I remember it's not too long ago when I finished grad school, about 3 years ago. And in my last year, I was like a little bit torn, like 50-50. Shall I go into industry? Shall I do or stay in academia? Because I think there are pros and cons on both sides. So I was like, which career path should I pick? And to be honest, I kind of deferred the decision until after my PhD defense, because the 2-3 months before your PhD defense are super busy. You're mainly occupied with writing your thesis. And I would say it was a lot of stress during that time. I thought, okay, maybe I'll finish this first. We'll take maybe 2 or 3 months off and then really think thoroughly about what I want to do next. Also during that time when I was working on my PhD thesis, there were some companies reaching out, and also luckily the Department of Statistics at University of Wisconsin, they somehow saw that I was graduating and they asked me to interview there because they just had a job opening there for an assistant professor position. And I was then doing my defense and at the same time just sending a quick application. And I was really lucky that they invited me in February to do the interview. So I did a few interviews also in industry and also at the University of Wisconsin-Madison. And during my visit, I got really excited about the idea of staying in academia. So I was in that time thinking a little bit more about it. And then I visited Madison and I really liked the city, the department, the colleagues there, but also most importantly, the vision there that we wanted to get more into data science. And right now, so since I joined, there are also all the promises came true basically. So there's a new data science major that we have. There's the Data Science Institute that we have, a new institute for doing data science and also facilitating data science research. But then we also have the new School of Computer computer, data, and information sciences, which is kind of merging computer science with the statistics and also the information school. And I think this is super exciting. I really care about teaching, as you may know. So I do both research and teaching, and also that is one of my of the things I enjoy, like helping other students or helping students to be successful and passing on the knowledge next to doing research. So in that way, I thought a position in academia would be quite perfect.
All right. So are you still considering, moving to the industry sometime soon? Or?
Right now I'm happy. I don't have any particular plans, but you never know what the future brings. But yeah.
All right. Yeah, Dr. Sebastian, when did you decide machine learning was for you and you wanted to do research here? What's the story like?
Yeah, so that is also another interesting question. It's a long time ago, going back to grad school. So when I was in grad school, I studied quantitative biology, basically biology computationally. So I can remember when I talked to my PhD advisor back then in 2011, 2012, I told her basically that I really just want to work computationally. That was my passion. Because as you know, maybe some biologists, or actually the majority, work like on experiments, wet lab experiments. I was more like always a computer person, and I like numbers, statistics. So I also early on in grad school, I signed up for classes related to statistical pattern recognition. So I think it was 2012. I took the introduction to statistical pattern recognition, which was CS 801, like a grad level course, and I really got fascinated by that. That is I would say it's related to machine learning, but it was more focused on traditional pattern recognition. But still, all the techniques presented there, they really fascinated me, because it was essentially also about teaching the computer to recognize pattern and doing classification. And that was more based on, I would say, statistical techniques, Bayes classifiers, also naive Bayes, and all the more statistical related things. And then I, by myself, started to study it more from a computer science perspective as well. I took a data mining course, and then I just was reading through textbooks and just trying to absorb as much as I can, and got really fascinated by what you can do with machine learning, and then later also deep learning. And I think also then kind of having the idea how you can relate and apply that to practical problems then in computational and quantitative biology was what really fascinated me, which is, I think, what got me into doing machine learning and deep learning research.
Such a fascinating journey. Of course, moving from the computational biology side of things to machine learning as a field. Thank you so much, Dr. Sebastian, for sharing your journey with us. Now, what were the specific challenges you faced while starting out in the field of machine learning, and how did you overcome such challenges?
Yeah, that is also an interesting question. So maybe that's also related to the statistical pattern recognition class I took back then in 2012. Because our homeworks were due in MATLAB. So that was maybe one major challenge, writing MATLAB code. I mean, MATLAB is not bad, but I'm just saying it's, I think, for me, I'm a very applied person. I like to tinker around. So I, of course, also write down equations with pen and paper, but I ultimately want to implement them and try them out to get a better understanding. So back then, that was 2012, the machine learning landscape in, let's say, Python wasn't so developed yet. There were a lot of tools and libraries out there, but also, as you know, MATLAB is proprietary, so you would have to have a university license or company license. There was Octave back then, but everything was a little bit rough around the edges. There were not many tutorials on the internet, so you had to kind of work by yourself to kind of develop these things. So what I did is essentially I took the textbooks, there was just equations, and I turned them into code. So that was when I started blogging about principal component analysis, linear discriminant analysis, kernel density estimations, and things like that. So I kind of, maybe it was also a advantage, but I kind of was forced to implement things myself if I wanted to have them in Python. But it's also a great learning experience. But I think the challenge back then was really the shortage of, I would say, hands-on material. And nowadays, I think it's hopefully a little bit easier, right? So there's a lot of material now in books, but also YouTube and blog articles. But yeah, so that was, I would say, one of my major challenges. Nowadays, though, I think there's a new challenge. Now that we have so many resources, I think it can be hard sometimes to pick the right one. So you can easily get maybe distracted by reading too many tutorials that are similar. So you kind of relearn or reread the same thing, and it's also not very productive. Instead of, let's say, going to the next challenge, to reading or working on something more challenging, you can maybe sometimes get stuck learning about the same thing over and over again.
Awesome. Thanks so much for that insight, Dr. Sebastian. Now, you mentioned, of course, books being a resource, and that's where I think our next question will come in, because you wrote the Python machine learning book, which has helped a lot of practitioners get started today, and helped a lot of people get started in machine learning. So here goes the question. What does it take to write a good book in machine learning?
Whoa, that's you have a lot of interesting, tough questions today. So, what does it take? So that kind of implies you're saying it's a good book, which I'm happy to hear.
It's one of the best books.
Whoa. Yeah, thank you. I appreciate it. So, what does it take to write a good book? I mean, back then I wrote a very, very small book. It's more like a pamphlet. Before this book, it was about heat maps in R. And I got maybe a little bit experience there, but ultimately I just started from scratch. Basically, I didn't have much experience. I think what helped me was a little bit about knowing about the audience. Like, should it be more like a practical or theoretical book? Because there were a lot of theoretical books out there already, but there wasn't that much of a practical book out there. So in that way, I kind of felt very motivated to write something to provide, let's say, more hands-on experiences to people. So the motivation and knowing your audience. But then also thinking about, when you write a book, is the book more like for teaching or informing people or like reviewing? So I would write a book differently for academia, for, let's say, professors who just want to learn about the theory because maybe they don't implement the code themselves. Maybe they are just more like trying to get an overview of the field. I would write such a book differently from, let's say, a book where I really want to teach people to do things hands-on, like for, let's say, grad students who want to use it in their research and also want to see maybe some code examples. So I think it's important to think about who the book is for. But then also, I think I had one advantage, that I was relatively new to machine learning. I maybe had a few years of experience, but I didn't have decades of experience. So I think that was also an advantage. I think it's good to know as much as you can, but then I think there's also the danger. I noticed that nowadays sometimes when I'm teaching, that if you know too much about a particular topic, you sometimes get bogged down into detail. So by that, I mean that you explain something, but you know there's more to it, and then you start getting more, I would say, you cover too much detail, and it's getting confusing for students if you cover too much detail too early. So it's sometimes also helpful just to, even though you know, okay, this is just a very brief summary, just keep it simple also, and then maybe go into the details later. But it's I think an important skill to know when to stop, that you don't describe things in too much detail. And also together with that, I think it's very important to do good planning, to think about the contents and how they connect. So for the Python machine learning book, there's, for example, a little bit of, some people like that, some people don't like the order, but I was back then thinking really hard about how to organize things. So what I wanted to is first explain things with very simple examples, like having something, implementing it from scratch, and then kind of understanding how machine learning works. I implemented for that a perceptron algorithm in the second chapter. And then also the Adeline, which is an adaptive linear neuron that I use to explain gradient descent and stochastic gradient descent. But then the other chapters in the book, they go into different topics like model evaluation, hyperparameter tuning, but then also how to use scikit-learn. And then later in chapter 10, I go back to neural networks. So there I kind of need the ideas behind Adeline again, and these ideas using a nonlinear activation functions are then used to build up a multi-layer neural network. So it's a little bit odd that you go, let's say, perceptron, a single layer neuron in chapter 2, and then come back to it in chapter 10, and everything in between is unrelated. But I thought I could have done this differently, but neural networks are a very complicated topic, and also, it's important to know about, let's say, basic scikit-learn, how to use it, do model evaluation. So it was kind of hard to find the perfect solution, but I think it's just important to think about these things before you write this, and also do some planning and think about how you present the topics in order. I should say I'm happy with the order in Python machine learning. That's what I finally decided to, but other people think differently. And it's important, I think, to think this through. And then it helps you with the writing, because then you know you can refer to other resources later. And then it's kind of a smooth journey. It's not like piecing together bits and pieces there.
All right. I think that's those are great insights for people who are looking to write great books like Python and machine learning. Of course, speaking of Python machine learning, it's a really introductory book for beginners. So listeners, if you haven't gotten that yet, just check it out. Links will be in the show notes for you to grab your copy of the book, the amazing book, by the way. Now, Python machine learning, of course, is an introductory book. But let's try to hear from the horse's mouth himself, of course, Dr. Sebastian Raschka. How would you advise people getting started in machine learning and AI today to learn? And of course, you're a fan of open source as well. You of course, they'll want to contribute to open source early on in their career. And how would you advise them to learn machine learning today? And of course, contribute to open source machine learning projects early on in their career?
Yeah, that's another interesting question. So, there are two parts to it. How I would advise people getting started with machine learning and AI today, and then the open source part you mentioned. So let me maybe address the first part first. So I think there are a lot of resources out there right now, like I mentioned before. Yeah. And I think one of the important aspects is really to stay focused. To maybe a good idea would be to just write down or do some research what resources are available, like articles, books, online courses, and then make a curriculum, like writing things down in a way that you think makes sense, but then you may go back and revise the content, but just to make sure that you also have a progression there, that you don't cover the same topic over and over again. For example, sometimes if a topic is very difficult, it makes sense to read chapters about the topic in two different books, for example, because things may be explained a little bit differently. But if you don't find that challenging, let's say the topic, then skip to the next topic. Don't get hung up reading about it over and over again, because while this is not harmful, it kind of it's not the most productive way to learn. It sounds tough to say, but I think the most productive way to learn is really to struggle, to have some challenge, because if you're challenged, then you get the best bang for the buck, I think, in terms of investing your time to advance your skills. But then I think also what's very important is to find something like a small community, like classmates, like taking an online course together or reading a book together in a way that you can have exchanges on a regular basis, that you have like discussion groups where you explain maybe even things to each other. I think that's maybe a very good way to kind of learn also. I mean, for me personally, it helps a lot to explain things to others, because then I realize what I don't know, and that helps me kind of learn new things. And also the exchange itself, there's something about having discussions that makes learning very productive, I think. Yeah. So for that part, I think choosing your resources or material wisely, because right now there's a lot of stuff out there, and try to stay focused, but then also find communities to discuss things and learn with others together. I think that's also making the whole thing more fun rather than sitting alone at home and just studying by yourself. So I think it's another important thing. The second part was about open source. Yeah, as you know, I really like open source, and I usually always recommend students to participate in open source. I think nowadays it's also part of a resume or a CV if you apply for, let's say, a position, to have, let's say, even your GitHub repository link on the CV or resume. So in that way, it is important, but I think there are only so many things. What I want to say is there are a lot of machine learning libraries out there, and I'm not sure if it's the most productive thing to develop another machine learning library. So in that way, I think the most useful thing is to look for machine learning libraries that are going to be around for a while, where it's like worthwhile spending time on making them better. One of them is, for example, scikit-learn, and they have a very nice community of people. People are super nice there, and also they have do nicely is they have an issue list on GitHub that is curated, where some are tagged like for beginners, like an easy issue to fix, and that it helps really people, I think, getting their feet wet with participating in open source, contributing. And I think one of the reasons why open source contributions are important and useful is that you can learn a lot by reading other people's code. It's you can see things from a different perspective, and then also discussions can happen. When you implement some code, someone has maybe some feedback for you, or if you see someone else's code, they've maybe accomplished something or done something, implemented something you have never thought about before implementing in this way, and then you think about, is it maybe good or bad, or is it something? At least it's something that exposes you to new ideas. Basically, it's otherwise you do your thing always your own way, and then you never kind of learn something new. And in this way, you see things from a different perspective. But then I think when it comes to machine learning and AI, beyond just code contributions or improving, let's say, tools, I think it's also nowadays very interesting to work on cool projects, like applied projects. So that with that, I mean, not writing the code for the sake of developing a library, but more like writing your code to solve a particular problem. It could be code that is not just for the library. It could be code to clean a particular data set, for example. And I think by that, you also will gain a lot of experience. And then I would say, instead of just only considering code contributions to, let's say, scikit-learn, also maybe look for interesting competitions on Kaggle, or maybe you have other like personal interests, like where you can where machine learning can be applied, and then also finding maybe a team with whom you can solve that challenge, and then put your solution, let's say, on GitHub, or maybe even write a short blog post or a preprint paper. I think that's also a very good investment of your time nowadays.
Yeah, absolutely. And Kaggle competitions, like you mentioned, Dr. Sebastian Raschka, is of course one of the prominent ways to add to open source. And we have, of course, our own Kaggle in Africa here. We call it Zinki. It's like Kaggle for Africa, pretty much, where we solve African problems with online data science competition.
That sounds really cool. I will look it up afterwards. I've never heard of it. That sounds really cool.
Africa. Yeah, awesome. Yeah. Now, speaking about Africa, this podcast is tagged The African Data Scientist, and what we try to do is to, tell the story of the African AI and data science potential. How do you think developing countries, especially in Africa, can thrive in this age of AI, where AI is becoming rapidly evolving as a field on its own, in its right? How do you think developing countries can thrive in this age?
Yeah, I think that's an interesting question. So it's maybe related to what you just said about having your own version of Kaggle. I think Africa is very unique, and there are so many unique people with experiences that are different from, let's say, other countries. I think it would be very interesting and important to focus on the local issues or problems and challenges, and develop AI system to really address problems that are maybe where people in other countries are not aware of them. I think that might be something where Africa can really thrive in the way that you would develop local solutions, but then also leveraging all the domain knowledge that you have. A lot of people in other countries are not that aware of issues that exist in Africa, and they only develop systems that are maybe only having applications in their countries. For example, right now, self-driving cars and things like that, that's maybe not a priority in Africa right now. I think in that way, leveraging unique experiences and the domain knowledge, I think that would be something where I think Africa can contribute a lot to AI. But then also things like language development. Africa has a high diversity, as far as I know, in terms of different languages spoken there. So compared to, let's say, the US, and I think that will also kind of be useful to consider that in the development of natural language processing systems to just experiment with new data sets and develop general solutions using unique data sets and different data sets.
All right. Thank you so much, Dr. Sebastian, for that insight. Talking about natural language processing is, in fact, I think one key area, like you said, about the vertical industries, our domain knowledge and expertise. And most of our listeners here are Africans, and we hope, of course, they take the valuable insights from your knowledge here today. Now, I know you've worked in a research lab, have you, Dr. Sebastian?
Mm-hmm. So I have a very small research lab with my students. Okay. That's right.
I know you, of course, you also spent most of your time in academia. How would you advise a small research lab in Africa, starting out in AI to sort of like navigate their early phase? And what do you think they should aim at?
Yeah, I think also that goes with the previous question, where I think it would make sense to leverage the local resources in terms of data sets and problems. And from there, really, I think using the domain knowledge of this, also the interests, like tailoring it to something where people feel like if they work on that problem, that they accomplish something really big, that they have really a contribution to science and also the community, especially. I think if the problems can be formulated in a way that they have a high impact to local areas, I think that might be very motivating to see then how it really affects the local problem area.
All right, awesome. Yeah, so moving on with our questions. Now, for universities in Africa, that want to adopt data science to their curriculum and perhaps skill up lecturers and professors with AI, how would you advise them to go about it? Having seen that you've served as you're currently serving as the associate professor of statistics at the University of Wisconsin.
Yeah, so I think it is, it's certainly not easy to design a curriculum from scratch.
Yeah.
So I would say it is just a suggestion, but maybe it would make sense to also do it gradually. Like Rome wasn't built in one day. So in that way, I think first, the most important part is getting people, that includes lecturers, instructors, but also the students, interested in the topic, right? So we can't, it's a very hot topic, data science, machine learning, and so forth. Absolutely. But I don't think we can just take it for granted that everyone is super excited about it. So I think with that, it might be nice to start with something like giving guest lectures. Mm-hmm. Okay. So maybe having some people in your community who are already interested in machine learning and data science to give guest lectures in related fields, like could be economics or even agriculture and other fields, to just have some very interesting applications of machine learning, or talking about how machine learning and data science could have an impact in getting people interested in that way. And I think also nowadays, so one of the positive things about COVID-19 is that lots of things have moved to online right now. Yeah. So in that way, I think there are also opportunities for lecturers and professors to join, let's say, conferences more easily, like attending virtual events, and then maybe also partnering with other universities, learning about things like curriculums from other schools who are already having a curriculum, and then taking maybe some ideas from there, adding elective courses maybe to your school, like having courses that are where the credit points can be transferred to your main course of study, but starting course by course, not, let's say, designing 10 courses at once and having a degree, but adding like an introduction to data science that many students can take in other fields, and then building up from there, like doing it one by one. And then after you have these elective courses, maybe merging them into a data science or machine learning degree at some point. But I think it's just challenging to have like a whole degree from scratch, like from one semester to the other. So I think doing it gradually, that might be something that could work or could work well.
All right, awesome. Thank you so much for that insight, Dr. Sebastian. Now, of course, looking at you've given us good insight for how they can adopt curriculums. Now, for instructors and lecturers out there in African academic ecosystem, what's the best way? What would you advise to be the best way to teach machine learning in this day and age for them, for these instructors and lecturers looking to teach in the African ecosystem?
Mm-hmm. Yeah, I would say so. It's all very hypothetical because I haven't been actively tried that yet. I don't know if that's good or bad advice, but I would say I wouldn't completely throw out all the kind of traditional teaching, because it has worked for a lot of people. So a lot of people who went through the traditional route, like classic textbooks and teaching material, they've become successful researchers. So I wouldn't completely throw this out, this idea. But also, I think related to what I said earlier, I think having very motivational applications to inspire students, because once you inspired students, they will also learn by their own. Because I think if you just go through textbooks and nothing else, having no kind of relevance to current or local problems, then I think you just learn for the sake of learning, to get good grades or something like that. But once you see how this could be used to solve some of your problems or problems that are very close to you, then I think when you get really motivated, you will learn more easily and you will absorb more knowledge and study by your own. And the learning experience will be just more fun, I think. So in that way, bringing the machine learning together with the local problems again to kind of show some relevance behind it, that it's not just a way of, let's say, getting good grades if you study or maybe making a lot of money, but also to really help people and solve problems.
Yeah. Oh, okay. Awesome. Really good. I hope our listeners who are, instructors and lecturers get to take something out of that. Now, talking about the academia once again, what do you think a lot of people often get wrong about researching ML and AI that you think that, it's not really concrete?
Yeah. So I think machine learning and AI, they are very fascinating topics and they are super exciting to study, at least from my perspective. But I think one thing that people often get wrong, this is more like for people who maybe haven't done research in machine learning and AI, is some people, I think it's partly due to the media, they think it's a magic bullet that you just apply it to something and it will do the right thing all of the time. So for example, I just yesterday had a conversation with someone asking about whether we can develop an AI system to make decisions in court, like court rulings and deciding whether someone should go to jail or not. And I think there are lots of problems with would be lots of problems with that. Also, let's just say there's no issue with biases and stuff like that. Even then, I think it's not just straightforward to apply a system like that. I'm not even sure. I haven't thought about this much because we just had the conversation yesterday, but I don't even think it's ethical to do something like that, or at least not with the technology we have. So I think one of the things people often get wrong is it's just also people sometimes think like, okay, you can just use AI to apply to a certain problem and it's just like a magic bullet that will do the right thing. And it's also easy to do that. And it certainly is not easy. If you look right now, we can apply machine learning or AI maybe relatively well to image classification, maybe some text classification, generating some text, but that's about it. I think going beyond that, we are not there yet. It's not like the super magic bullet, and it's not like that we don't even have self-driving cars yet out on the street. So in that way, I think everything is very experimental, and we have to take things with a grain of salt right now. We can't expect too much right now, and I think that's one of the problems, that it's the way it's communicated. It's sometimes making it look more than it is, and then people get disappointed when things don't work out as well.
Yeah, absolutely. The hype and all of that, taking people's expectations up. Thank you so much for that clarification, Dr. Sebastian. Now, I'm talking about research. I know lots of our listeners out there today are looking at becoming researchers, others becoming engineers and probably research engineers. Someone who is getting started or who is already in the space of research, what qualities do you think they need to become a world-class researcher in the fields of machine learning and AI?
Yeah, I think for that, if you want to get into machine learning and AI, and I think what it takes really is motivation. That's true for any kind of field, that you have to be motivated to work on that, and also be able to kind of narrow it down to aspects that you are particularly interested in, because machine learning and AI is a very big field, and it's right now already impossible to know all about all of the fields or subfields. So in that way, I think it's important to, at some point, to develop a special interest in a subfield. Could be, the subfield could be maybe even broader, like image classification. But for example, splitting your time between image classification, natural language processing, and let's say reinforcement learning or for developing self-driving cars, doing all three things, that could be overwhelming. So in that way, I think focusing on something where you are really motivated about to develop new solutions, that would be something. But then also on a more broader scale, I think it's very important to learn how to say no to distractions or opportunities even. And that's also what I'm having a hard time with. So to be careful not to say yes to everything. So you may have noticed I wrote the book like in 2015, the 2 updates, but I haven't written any other book right now. And that is because I would really like to write another book, but I know it takes a lot of time, and the day has only 24 hours and you can't do everything. So in that way, it's sometimes important, even though it's interesting to you to say no to things. It's hard, but it's, I think, an important skill to keep focused. Also, maybe having not too many research problems, because then you get spread too thin. And then it's more about quantity than quality. And I think, time management is really important. But then also in the end, having some patience, because it takes years to develop the skills to be good at something. And it's not just a month or a course. It takes multiple courses to learn really about a topic, and books that you need to read. So patience is also some very important skill, I think.
Patience, time management, and learning how to say no. I think these are absolutely good qualities you've recommended, Dr. Sebastian. And thank you so much. Now, of course, looking at the machine learning landscape, now, what do you think is changing in the machine learning landscape in the next 3 or so years that you think people should know about? Because right now, of course, you're into the research space, and of course, it's when things are successful in research that they are pushed to engineering and made use of by people. What do you think is changing in this landscape in the next 3 or so years?
That's that's like a very hypothetical question. So what's happening in the next 3 years? So. Everything I'm going to say now is just speculation. I have no idea what's going to happen in 3 years. But what I think is there will be maybe not so many fundamental changes in the way that we do or implement machine learning AI systems. So I think we will still be using deep learning architectures that we have now, maybe modified versions of it. I think we will still use backpropagation in 3 years. But what I think is that we change is that we are maybe more conscious about resources. So on the one hand, if you look at all the language models with billions of parameters right now, it's getting bigger and bigger and bigger. That is for certain applications. But then at the same time, there's right now a lot of discussion about privacy. And one of the problems is that most of the applications on your cell phone, what they do is they use some server backend. So the cell phone picks up the data, but then it's sent to some server, and then it's doing the machine learning AI part and sends you back the results. And that may change. I don't know, but I think if people, let's say, are becoming more concerned about privacy, there are more regulations being implemented, then researchers have more of an incentive to develop systems that work locally on your cell phone. I think Apple just did that, or announced that at the WWDC in like a few weeks ago in summer, that I think they have some language model that will do text or speech translation on the phone compared to, let's say, sending something off to servers. So I think something in that, I think direction might be becoming more popular in the future, that people develop smaller systems. Cell phones are becoming more capable, but at the same time, you can't just still not have like billions of parameters on the cell phone. It will be way beyond the cell phone's storage capabilities. But then also you have to think about maybe tailoring your network to the application, like having some learning component, not that it is just some application that has been pre-trained. So in that way, you also want to have it efficiently updating. But then also going away from the privacy stuff, what I think is also becoming hopefully more popular is that people will start applying machine learning to domains outside of text and images. So right now, many applications are related to text analysis, speech and image classification. That is, I would say right now, more like the low-hanging fruit. Where it becomes, I think, more interesting is to think about how these technologies can be applied to data that is not text and data that is not images. So one area where I'm kind of involved in or I'm currently working on is computational biology, in particular small molecule analysis, discovery, and analyzing how small molecules and proteins interact. And this is neither text nor image data. The molecules are small graphs, or small molecules are small graphs, but proteins would be big graphs. So you have graphs, graphical data in that way. So there are nowadays more, or actually a lot right now, techniques for graph neural networks, so deep learning with graphs. So that is one way deep learning has been or is now being applied to data that is not text and images. But I think, it would be exciting to see more of that in other application areas where machine learning is usefully used on data that is not text and images.
All right. So for these applications you're looking at, are these applications also what you're excited about in the future of machine learning and AI, or there's a completely different thing you're excited about looking at the future of this field?
Yeah, I would be, of course, very excited about seeing something that is not backpropagation, some new algorithm for training neural networks. Yeah. I mean, it's just I'm not sure if that is feasible. If there is something, I mean, I think no one knows, but I would be certainly excited about that. It's not that things don't work well yet, but backpropagation, for example, has been around for 30 years, and I'm always open to changes. No, but seriously, I'm excited about really seeing applications of deep learning, like I said before, on data that is not text and images. Right now, all the graph neural networks are very experimental. They are right now relatively new, have been developed maybe in the last 1, 2, 3 years, and seeing that really to apply to real world problems, like even something maybe now for COVID related issues for discovery there of like certain antigens and things like that. So for that, I think I would like to see really like applications also of deep learning to things that are not text images. That's what I'm excited about.
So, okay, looking at other verticals, right? So, of course, you spoke about molecules and everything. Just to digress a little bit, what's the progress like coming to the side of computational bio statistics and all of those things? What do you think what's the progress like in such field?
Yeah, I think computational biology is a little bit traditional. There's a lot of stuff available that has been developed decades ago, which is super useful. There's a lot of domain knowledge, and I think domain knowledge is very important in that field. It allows you to, so because the reason is if you develop or find a ligand that binds to a protein, there's always maybe not an optimal interaction between the two. So you can, with chemical knowledge, you can optimize a molecule to bind better to the protein. And in that way, I think it's also important for an AI system to kind of be able to make suggestions such like predicting what changes make a molecule more active, for example, binding more tightly. But then at the same time, what limitation is currently also is that we are screening available databases. So there are databases of millions of molecules. We are just screening them to discover something. And it is working well. So you just test or you apply your predictor to all the types of molecules there. But then maybe we are not very efficient with our time. Maybe it would be more efficient to not screen an existing library, but maybe synthesize a molecule from scratch. So let's say I have a protein binding pocket, and instead of just docking all the small molecules into that binding pocket, what I could do is I could maybe synthesize the molecule. So I could just create the molecule in the binding pocket without even considering my data set. The only condition would be, of course, that this should be a molecule that could be synthesized so that a chemist can make, basically. But we still need chemists and domain knowledge, because even if we do a prediction, we need people to, if they don't exist yet, to synthesize these molecules, and they have to know how to synthesize the molecules. And then also you have to have people who are able to do the experiments that you have to do to validate the results and things like that. And right now also all the computational techniques are very, I would say, rough. They are more like filtering. So what you do is basically you start with a computationally cheapest technique, apply it to all the molecules, and then you filter out candidates that might be promising. And of course, there are a lot of false positives, but there are also a lot of false negatives. So you're going to include some molecules that are not interesting, but then you also miss a lot of molecules that may or could have been interesting. So there are a lot of challenges where I think also traditional techniques are still useful, where you can apply them together with different, it's like an ensemble of techniques where you approach the problem from different perspectives, and then you combine or integrate these perspectives to get better results.
All right. Thank you so much for that insight, Dr. Sebastian. Now, talking about solving problems with, AI, do you have any advice for people starting to apply machine learning to real world problems? whether it's through a company, which of course is a startup, or a non-profit, or through a government body?
I think maybe I would start with an existing problem. It's picking something you are somewhat interested in that is maybe somewhat related to a problem you really care about. Maybe looking for something related on Kaggle, and then maybe doing some competitions on Kaggle just to develop your skills and see to have like a reference to see whether how good your skills are, or if you are doing it the right way, in a way that that you can have something to compare your results to. Because if you have a new problem, you never know what the threshold is. Is 60% accuracy good? Is it not good? For example, just to say something trivial with accuracy, but it's hard sometimes to develop something where you don't know whether it's good or not. So of course you can say, you can think about the problem. What do you care about? Is this a meaningful measure? Is this a threshold where you are happy with deploying the system? But also when you just start, I think it's important to first of all get some motivation to see something that works. So, and in the real world, working with new data is always messy. It's very challenging. It takes a lot of time to obtain a label and clean your data. So maybe starting with something where someone has done the hard work for you and you do the fun part, the machine learning modeling, that would be something to start with, I think, doing that for maybe, the first couple of weeks or months. And then, starting to think about how you obtain data for the problem you care about, and then planning that problem, and then also maybe seeking collaborations, because it's still very important to have someone who knows about the problem from, let's say, not a computational, but really a real world experience, to have some domain experts to help you or guide you, and someone also you can talk about if there are, let's say, weird things in your data set where you can ask someone about, does it make sense? Is there some issue with my data? And what data can I get from you or from people who have worked with that, so that you have broader perspectives? Because right now, I mean, just a trivial example, I'm one of the moderators of the machine learning category on Archive, and there are a lot of papers right now that are applying convolutional networks to X-ray crystallography. No, not crystal. I'm mixing it with computational biology. Sorry, X-ray pictures of lung images of lungs for COVID detection, and there are maybe hundreds of papers right now working on that level of prediction. So maybe collaborating with domain experts would be useful to ask what other types of data could we get from you that we can develop machine learning systems that can, let's say, predict whether a patient has COVID or not, without, let's say, requiring a PCR or a sample like a saliva sample. So is there another way maybe we can do an accurate prediction of COVID? So instead of just everyone is using these X-ray images of the lungs, is there something else? And as a machine learning expert, you may not know, because you only work with the data that is, let's say, available somewhere. So in that way, I think it's important to collaborate with domain experts also, and also just to see whether what you're developing is really useful, basically.
Yeah. All right. It's been a wonderful conversation with you, Dr. Sebastian. I actually learned a lot, and I hope our listeners are learning, or of course, we'll learn a lot as well. Now, on the final note, do you have any departing thoughts for our listeners?
First of all, time was running like always. And I really enjoyed the conversation. And for the listeners, I would just say, stay motivated, stay curious, and start learning and have fun.
All right. Thank you so much once again, Dr. Sebastian Raschka, for joining us today. Dr. Sebastian, once again, is the author of Python Machine Learning book. Every links we mentioned will be in the show notes if you can expose that to make sure that you get on point with this. And see you next time, guys. Bye-bye.